Hello then, so this lesson today then is the first of Unit 14, which is all about multiplicative reasoning. So in this lesson we're going to have a look at percentages. So the key things to do in this lesson then are going to be able to calculate the original value after a value has been increased or decreased by a given percentage. This is often called reverse percentages. We're also going to be able to calculate the percentage change when we're given the original value and the new value. So let's first of all then have a look at our prior knowledge. So things we need to know to be able to complete this lesson. So you need to be able to find percentages of amounts. So I've shown a few simple ones there for you to check. You also need to be able to change between percentages and decimals by dividing by 100, either by doing this in your head or by using a calculator. The most important bit of prior knowledge you need to have though is to be able to calculate percentage increase and decrease. So this was covered in Unit 4, so this might have been a little while ago. For some of you it may be something you need to refresh yourself on before you start. So I've given a couple of examples there of the sorts of things we would need to do to increase or decrease percentages. So pause the video now and make sure you're happy with those before you continue. Okay, so as a bit of a start today, then we're going to do a recap first of all on percentage increase, just to make sure that you are happy with it. So we want to increase £50 by 60%. When we increase an amount by a percentage, we actually have 100% of the amount already. So by adding on 60%, we actually require 160% of the £50. To find 160%, to be able to put that into our calculator, we need it to be a decimal multiplier. To change a percentage into a decimal, we divide it by 100. So 160 divided by 100 is 1.6. So we're going to do 50 times 1.6, and that gives us an answer of £80 exactly. Our second one then. We're going to increase £24 by 35%. Again, we have 100% already. We want to increase it, we want to make it bigger by 35%. So in fact, we're going to find 135% of the value. We need to change our percentage to a decimal, so we're going to divide it by 100 to give us 1.35. So 24 times 1.35 gives us £32.40. Now do note in your calculator it will simply say 32.4, but because we're dealing with money we should have it to at least 2 decimal places, pounds and pence for money. So just make sure you add in that extra 0 at the end. The next one then, we're going to increase £86 by 17.5%. So again, we have 100% already, so we're going to actually find 117.5%. Now we still need to turn it into a decimal. At the moment it's a percentage, it's got a percentage sign at the end, so although there is a decimal point in it, it's not currently a decimal value. So we still need to divide it by 100 to turn it from a percentage to a decimal. So changing 117.5% to a decimal gives us 1.175. So 86 times 1.175, and we get 101.05 to the nearest penny. Finally then, increasing £300 by 2.5%. So again we have 100% already, so we're going to add on 2.5, so we want to find 102.5%. Let's change that percentage into a decimal multiplier by dividing it by 100, giving us 1.025. 300 times 1.025 is £307.50. So again, making sure we add the extra 0 on there ourselves. Pause the video if you need to, check through those, make sure you're happy with being able to increase and that you understand how to change a percentage to a decimal multiplier for increase. Okay, a quick recap then on percentage decrease. So to decrease £65 by 20%, well again we've got 100%, but this time we want to reduce it by 20%. 100 take off 20 means we actually only need to find 80% of the value. 80% as a decimal, again dividing by 100 gives us 0.8. So 0.8 times 65 is £52. Decrease £56 by 34%. Again, we have 100%, so to decrease, we've got to take off the 34%, so we're only finding 66% of £56. Let's change our percentage into a decimal multiplier, divide it by 100, gives us 0.66 times £56, which is £36.96. We're now going to decrease £320 by 3.5%. Again, we started with 100%, so we've got to now take off the 3.5%. That means we're only finding 96.5%. Again, let's turn that percentage into a decimal multiplier. So although it has a decimal point in it at the moment, it is still not a decimal. Divide it by 100 gives us 0.965 times 320, which is £808.80. Finally then, we're going to decrease £1,570 by 95%. Now again, if I have 100% and I take off 95%, I'm only actually finding 5% of the value. Divide 5 by 100 to get our decimal multiplier, which is 0.05. Now make sure you're careful with that one. Often people forget to move 2 decimal places backwards and we end up with 0.5. Now 0.5 is 50%, so any single digit percentage is going to have an extra 0 in front, so 0.05 times 1,570, and that comes to £78.50. So again, pause the video if you need to, check through your understanding of decreasing percentages. Okay, moving on then, the main part of the lesson. We're going to start with reverse percentages. So as it says, sometimes we're given the result of a given percentage increase or decrease, and we have to find out the original amount. So it says I bought some jeans in a sale, they had 15% off, and I only paid £25.50 for them. What was the original price of the jeans? Well, if we think about how we would work that out normally, we would normally say that the original price of our jeans, we're going to call that P for now, we would multiply it by 0.85. Remember, we're multiplying by 0.85 because they were reduced by 15%. So 100 minus 15 is 85%, and 85% as a decimal multiplier is 0.85. And we know that that should come to £25.50. So the reason this is called reverse percentages is because we want to know the original price. So we need to do that equation in reverse. Now when we reverse an equation, we use our inverse operations, meaning we do the opposite. So if we start with the £25.50, instead of multiplying by 0.85, the inverse of multiplying is dividing, so we're going to divide it by 0.85. £25.50 divided by 0.85 means the original price of the jeans was £30. If we have a look at this in the diagram then, so we have our price before the discount. To find out how much that is, we would have multiplied it by 0.85%. That would give us the price after the discount. If we have the price after the discount, then we're dividing by the 0.85 to give us the price before, so we can work forwards and backwards. Okay, so let's have a look at an example then. So the price of a trampoline has been reduced by 40% in a sale, and the sale price is £90. What was the original price before the sale? So if we start off by writing down what we would normally do to get to that price of £90. Okay. So if I want to reduce it by 40%, we need to find 60%. So the original price times 0.6 equals £90. If we reverse that, then we'll do 90 divided by 0.6 was £150. So again, the most common mistake people make with this is because it's been reduced by 40%, they think that increasing the £90 by 40% will take you back to the original. And we can see that that will not work. So we've got to work out, well, how would we normally find that value of £90 and then reverse it to find the original value. So then it finally says, how much would you save by buying the trampoline in the sale? So it would have been £150. We've paid £90. So 150 minus 90 is a saving of £60. Let's have a look at one more example then, just to make sure we're happy. So the number of downloads from a website has gone up by 20% this month to 48,000. How many downloads were there last month? So again, we're going to start off with how we would normally do it. We'd normally have the original value. If I want to increase by 20%, that's adding 100 to 20% gives me 120%. As a decimal multiplier, that would be 1.2. So we know the original value times 1.2 would be 48,000. So let's reverse it. So 48,000, instead of multiplying by 1.2, we're going to divide it by 1.2, and that gives us 40,000. So last month there were 40,000 downloads. Alright, just make sure you're happy then with those examples and have a go at these questions. So pause the video now, work through as many of those as you can. There is a challenge question at the bottom for those of you who get that and are feeling keen, but read through each question carefully, show how you would originally find the value and then reverse it. Okay, so let's have a look at the answers for those then. So the first one then, we should have 170 divided by 0.8, £212.50. For the second one, 17.5 divided by 1.15, the box would have originally been £15. £98.80 divided by 1.04 gives us £95. 660 divided by 1.1 equals 600 millilitres. And 2.4 divided by 0.96 equals 2.5 metres. So you'll notice that if something has been increased, then the original value would be a lower number, and if something has been decreased, then the original value would be a higher number. Now let's have a look at the challenge then. So Rosie sells her laptop to John and makes a 15% profit. John sells the laptop to Michael for £391 and he makes a 15% loss. So how much did Rosie originally pay? So we need to start off then. We know that Michael's got the laptop at £391 and that was a loss for John. So a loss being a decrease. So if John paid £391, then we divide that by our 0.85 and that meant it was £460 when he bought it. So he bought it from Rosie for £460. Now she made a 15% profit when she sold it to John. So if we start with our 460, we're going to divide it by 1.15. So Rosie originally paid £400. To double check those answers, you can go back through from the beginning, starting with Rosie having it for £400, increasing it by 15%, and then decreasing it by 15% to see if we get back to the £391. Okay, let's move on then with the second part of this lesson. So we're going to have a look at percentage change. So sometimes we're given the original value and a new value, and we're asked to find out the percentage increase or decrease. So we can do that using this formula. So percentage change is equal to the actual change divided by the original amount and times 100 to change it from a decimal to a percentage. Pause the video now, make sure you've made a note of that formula. So let's have a look at how that works then. So Andy buys a bike for £300 and sells it a year later for £180. What is his percentage loss? So the first thing we need to do is to find out the actual difference between those two values. So the difference between 300 and 180. So 300 minus 180 means the actual decrease, the actual change in value was £120. So our formula said it's that change in the value divided by the original value. Now the original value of his bike is what he had it for at the beginning. It's often the first number in the question. So he bought it for 300. So that's the value we're going to divide by. So we're going to do 120 divided by 300 and times it by 100. To the nearest percentage, that gives us a 40% decrease. So another example then. Each week Nina buys a magazine. This week the price went up by 25 pence to £1.50. What is the percentage increase in price? So again, the two bits of information we need to know the actual increase. So we've been told that this time in the question. We've been told that the week it went up by 25 pence. So that's the actual increase. And we need to divide that by the original amount. Well, this time we know what it is now. We need to work out what it was originally. So if it's currently £1.50 and it's gone up by 25 pence, then we should be able to work out how much it is. Now, whenever we're working with units in maths, we need them to be the same. So it's worth changing our £1.50 into pence. That'd be 125 pence. So our actual increase was 25 pence. The original price was 150 pence minus the 25 pence. So the original price was 125 pence. Now we can use our formula. So it's our actual increase divided by the original price times 100, and that means it's gone up by 20%. Again, if you need to, pause the video, check through the examples, make sure your understanding is good. Okay, so some for you to have a go at. So we've got a table of different values here. So the cost of items that a shopkeeper has and the price he's selling them for. You need to work out the profit that he's made and then the percentage profit. There's again a challenge at the bottom for those of you who feel like taking that on. Pause the video now, have a go at these questions. Okay, so let's have a look then at that table. So the ring then, the actual profit, the difference between the cost he bought it for and his selling price was £3. So £3 divided by the original value, which is £5, times 100 is 60%. For the bracelet then, the actual profit is £6, and £6 divided by the original value of 12 times 100 is 50%. For the necklace, the actual difference there, 20 to 30 is £10. 10 divided by the original value of 20 times 100 is also 50%. And for the watch, the profit of £7 divided by the original value of 18 times 100 is 38.9%. So it's interesting to see that although he makes the most actual profit on the necklace at £10 difference, the percentage profit is actually greater on the ring. So looking at the challenge question then, if you had a go at this, so exactly the same idea, we've just got some longer numbers here. So we need to find the difference between our 64,105,700 and our 58,789,194. So that gives us a total difference of 5,316,506. We divide that by our original value. Again, the original value was the original population times 100. And to three significant figures, we get 9.04%. So well done to you if you had a go at that one and got that one right. Okay, so that's the end of this lesson for today then. So please don't forget to subscribe and click on to the next lesson where we'll be continuing with percentages.